A pleasant good morning to one and all. This is Maria Pushpam, and for today's class, we are going to see three different photophysical processes. And if you take this photophysical process, we have five different techniques. The first one is fluorescence, second is phosphorescence, then chemiluminescence, bioluminescence, followed by thermoluminescence. Okay, so first two methods completely we have seen. The first one is fluorescence and second one is phosphorescence. We have seen thoroughly. And for today's class, we are going to see the last three techniques: chemiluminescence, bioluminescence, as well as thermoluminescence. I'll go one by one. So I'll start with chemiluminescence. So coming to chemiluminescence, what I mean by chemiluminescence is it's a phenomenon of emission of visible light as a result of chemical reaction at a temperature at which black body normally does not emit visible light, and this we call it as chemiluminescence. I'll repeat. Can you understand? I'll repeat ma. The phenomena of emission of visible light as a result of chemical reaction taking place at a temperature at which black body does not emit visible light is known as chemiluminescence. And if you take this chemiluminescence, it's a reverse process of photochemical reaction, because photochemical reaction takes place only by absorption of light. And if we come to chemiluminescence, here because of chemical reaction visible light is being emitted. Is it okay? So this phenomena we call it as chemiluminescence. I'll repeat. So what I mean by chemiluminescence is it's a process in which emission of visible light takes place as a result of chemical reaction at a temperature at which a black body does not emit visible light. We call it as chemiluminescence. We have lot of examples. A few are given in the book. I'll say one by one. So first one, if you take phosphorus, phosphorus combines with oxygen to form phosphorus pentoxide and light is being emitted. Visible light is being emitted. And the second example is when a solution of strontium chloride is added to dilute sulfuric acid, and in a dark place it gives a feeble glow. That is, a light is being emitted. That is nothing but strontium chloride reacts with sulfuric acid to give you strontium sulfate plus hydrochloric acid with emission of visible light. And third one is a red light is emitted when chlorine or hypochlorite ion is oxidized by alkaline hydrogen peroxide solution. It gives, that is, reaction of hydrogen peroxide with chlorine gives a red light. And next one, a red light is being emitted when a mixture of pyrogalol and formaldehyde is oxidized by hydrogen peroxide. And the last example given here is when a stream of atomic hydrogen is allowed to fall on a surface of mercury, blue light appears. Is it okay? So these are the examples of chemiluminescence. I'll repeat. So what I mean by chemiluminescence is because of the occurrence of chemical reaction, visible light is being emitted at the same temperature. If you take a black body, it won't emit visible light, and that phenomena we call it as chemiluminescence. A good example is phosphorus reacts with oxygen to give you phosphorus pentoxide plus light. Second one is strontium chloride reacts with dilute sulfuric acid to give you strontium sulfate plus hydrochloric acid plus light is being emitted. Other examples are a red light is being emitted when chlorine reacts with chlorine is oxidized by alkaline hydrogen peroxide, and red light is also emitted when a mixture of pyrogalol and formaldehyde is oxidized by hydrogen peroxide. And last example is atomic hydrogen is allowed to fall on a surface of mercury, blue light is being emitted. So these are the different examples for the chemiluminescence phenomena. And next one we are going to see is nothing but bioluminescence. From the word itself you can understand bioluminescence is also said to be a chemical reaction taking place in living organism. If you take a chemical reaction taking place in living organism, it emits light, and this phenomena we call it as bioluminescence. So certain living organisms are there, they undergo chemical reaction within the body and light is being emitted. Since the phenomena is taking place in living organisms, we call the phenomena as bioluminescence. I'll explain. So how to define it? Certain living organism emit visible light as a result of chemical reaction, and this phenomena of chemiluminescence in living organisms, we call it as bioluminescence. I'll repeat. So what do you mean by bioluminescence is chemiluminescence in living organism. That nothing but visible light is being emitted because of the occurrence of chemical reaction taking place in living organism. We call it as bioluminescence. Example, fireflies produce yellowish green light. Fireflies. You have seen fireflies, yes? Fireflies produce yellowish green light. It is believed that this is because of the oxidation of luciferin, a protein by atmospheric oxygen in the presence of an enzyme luciferase, and the intensity of the light is found to be very very low, so it is observed only in night. மின்மினி பூச்சி சொல்லுவோம்ல, that we call it as firefly. மின்மினி பூச்சி அது பகலில் பார்த்தீங்கன்னா தெரியாது, இருட்டில் அது போகும்போது தெரியும். அதுக்கு பாடிக்குள்ளாட அந்த லூசிஃபரேஸ் வந்து ஆக்சிடைஸ் ஆகிறதுனால we get a color that is nothing but a yellowish green color light will be emitted, and that is a apt example for bioluminescence phenomena. Then if you take jellyfish, it emits visible light, second example. And third one is foxfire, which is it occurs in So if you take foxfire, it occurs in marshy places, which is due to the luminescence bacteria present in the decaying wood. மரம் வந்து decay ஆகும்போது அதில் marshy placesல இந்த foxfireலேருந்து we get visible light. A luminescence will be emitted. It's only because of the bacterial action taking place in the wood. And this phenomena also emits light. So this also comes under bioluminescence. So what do you mean by bioluminescence? Means bioluminescence is nothing but in living organism, chemical reaction take place by the emission of visible light. If is being emitted, the phenomena we call it as bioluminescence. In other words, we can say chemiluminescence taking place in living organism, we call it as bioluminescence. Example, firefly we can write, jellyfish, also we can write foxfire. Okay, and the last process in photophysical process is thermoluminescence. Okay, so what do you mean by thermoluminescence is, if you take certain substances can absorb light at room temperature and emit as visible light at higher temperature. This phenomena we call it as thermoluminescence. சில சப்ஸ்டன்ஸ் இருக்குது, அது என்ன பண்ணுன்னா நார்மல் ரூம் டெம்பரேச்சர் லைட் அப்சர்வ் பண்ணிவிட்டு higher temperature, that is these substances will absorb light at room temperature and emit visible light at higher temperature, and this phenomena we call it as thermoluminescence. Is it okay? Because of heating, light is being emitted. Is it okay? That is thermoluminescence. So what I have to say here is thermoluminescence is nothing but it's a process in which certain substances can absorb visible light at room temperature and they emit visible light at higher temperature. This phenomena we call it as thermoluminescence. Is it okay? Example is strontium sulfate, phosphor, is illuminated with light at room temperature. Then the light is turned off and phosphor is heated steadily at a temperature of 2.5 degrees centigrade per second. And visible light will be emitted and the intensity of the light increases up to certain temperature, then it decreases. It's clear now? So thermoluminescenceனா என்னன்னா, இட்ஸ் நத்திங் பட் இந்த ப்ராசஸ் எப்படின்னாமா நார்மல் ரூம் டெம்பரேச்சர் லைட் அப்சர்வ் பண்ணி வச்சுக்கும். சரியா? அந்த சப்ஸ்டன்ஸ் எடுத்து நம்ம ஹீட் பண்ணோன்னா ஒரு பர்டிகுலர் டெம்பரேச்சரில் பார்த்தீங்கன்னா உனக்கு அந்த லைட் வந்து க்ளோ ஆகும். திருப்பி நம்ம ஹீட் பண்ணிட்டே இருந்தோம், அந்த க்ளோயிங் இன்டென்சிட்டி வந்து ரெடியூஸ் ஆகிட்டே இருக்கும். ஸோ வெரி குட் எக்ஸாம்பிள் இஸ் phosphor is nothing but strontium sulfide. So if you take strontium sulfide, you keep it in normal room temperature, it can absorb light. You off the light. After offing, you take this you off the light and take this fast forward, then you heat to a temperature of about 2.5 degree centigrade per second வச்சு நம்ம ஹீட் பண்ணிட்டே இருக்கணும். ஸோ நீங்கள் பார்த்தீங்கன்னா ஹீட் பண்ணும்போது விசிபிள் லைட் எமிட் ஆகிட்டே இருக்கும், இன்டென்சிட்டி இன்க்ரீஸ் ஆகிட்டே இருக்கும் ஒரு குறிப்பிட்ட டெம்பரேச்சர் வர. அதுக்கப்புறம் பார்த்தீங்கன்னா நீங்கள் அதுக்கப்புறம் அதை ஹீட் பண்ணிங்கன்னா அந்த விசிபிலிட்டி ஆஃப் லைட் வில் பி டிக்ரீஸ். பிகாஸ் ஏன்னா அதை அப்சர்வ் பண்ணியிருக்க எல்லா லைட்டையும் அதை எமிட் பண்ணதுக்கப்புறம் வந்து நம்ம எவ்வளோ ஹீட் பண்ணாலும் அது எமிட் பண்ணாது. So the intensity slowly decreases. It's clear? So this phenomena we call it as thermoluminescence. I'll repeat this thermoluminescence once again. So what I mean by thermoluminescence is certain substances absorb light at room temperature and emit it as visible light at higher temperature. This phenomena is known as thermoluminescence. Okay, and a very good example is strontium sulfide. It has to be kept in light at room temperature. Then we have to off the light and take fast forward, and we have to heat it at temperature of 2.5 degree per second. As you heat the thing, the visible light will be emitted. The intensity of the light increases as you continue heating. Okay, and at a particular temperature it begins to decrease. The visibility will be diminishing, and beyond that if you heat there will be no visibility because all the absorbed light will be emitted. Is it okay? So this phenomena we call it as thermoluminescence. So we can have a short recap of the thing what you have seen for today's class. As a whole we have 5 topics in photophysical process: fluorescence, then phosphorescence, chemiluminescence, bioluminescence, followed by thermoluminescence. And for today's class we have seen 3 luminescence, that is chemiluminescence, bioluminescence, followed by thermoluminescence. I think you are able to understand the class. Thank you for listening. Continue studying. Thank you, ma.